The sub-scenario analysed how autonomous and connected vehicles, where the driver may be eventually requested to take over control, can be securely safeguarded from external threats when onboard and infrastructure-based information are fused together within the vehicle. Two different driving situations were considered using a highly automated vehicle in CSIC's urban-like proving grounds close to Madrid, Spain.
The SECREDAS Common Framework for Safety, Security and Privacy, developed within this project and considered as best practices, are used in this scenario to handle threats attacking an automated vehicle via communication channels.
Automated vehicles can get information through wireless communications from the infrastructure or from other vehicles, which provides a better understanding of the driving situation. So, in a first scenario, roadworks were notified and characterized through cooperative services based on wireless communications, which should help avoid potential threats, such as a very last-minute detection of the obstacle by the vehicle's onboard sensors, thus reducing the global planner's ability to replan, or the position of the communicated roadworks being hacked. Once the obstacle was confirmed by the under-test vehicle's onboard sensors, the automated driving function prevented the driver from taking control when approaching it. If the driver still preferred to supervise or was not ready to intervene, and the driving context was considered unsafe, a global planner automatically found an alternative route. A second scenario involved a cooperative service signage application, enabled by the presence of a stuck vehicle in the middle of the road, generating a potentially dangerous situation. In this context, in-vehicle speed limits were dynamically modified and awareness messages were sent to the surrounding vehicles. Before reaching the hazardous area, the driver was advised that a closer supervision was required. In such complex and unpredictable driving scenarios, human reactions can be inappropriate or time-shifted, and therefore the vehicle must analyze the driver's readiness to take control. In case the driver was in a drowsy state, the automated driving function enabled a safer and more conservative operation mode. In addition to that, an alarm was sent to the surrounding vehicles that an automated vehicle was nearby and could eventually represent a danger.
In the near future, mobility users will benefit from an enlarged operational domain where vehicles can self-navigate and a smoother authority transitions between the human and machine when these are required.